In the next 20 minutes, what I want to try and do is cover some of these things. I'm not going to be able to get into too much depth here. I want to talk about what climate change is just for a couple minutes. Then I want to tell you about some of the climate trends that are occurring based on some slides from the Minnesota State Climatology Office. And then just mention a couple words about climate adaptation. So just to quickly, in 30 seconds or less, explain what the greenhouse effect is. Sunlight comes in with shortwave radiation from the sun, comes into the earth. It hits the surface of the earth. It bounces back as infrared radiation. The infrared radiation is absorbed and re-emitted by greenhouse gases in the atmosphere. That's the phenomenon. It's been known about for many, many years, for probably about a couple hundred years, that greenhouse gases can absorb and re-emit heat. And that's what's causing the atmosphere to warm. There's three key human-caused pollutants: carbon dioxide, methane, and nitrogen dioxide. There are other pollutants as well, but these are all contributing. And as you can see, some of them have, methane is 21 times more powerful than carbon dioxide, but essentially these are all greenhouse gases, and they are all contributing to the increase in temperature in the atmosphere from this re-radiated heat from the Earth. This just shows a concentration of CO2 and how it relates to the increases in global temperatures. This is one piece of clear evidence for that we're seeing climate change. And this slide from the National Climate Assessment, which is a federal publication, just illustrates about 10 indicators of a warming world. We have more water vapor in the atmosphere because of more evaporation because of this heat. The oceans are becoming warmer. We're seeing less sea ice. We're seeing less polar ice. The temperature over land is increasing. Sea levels are rising. There's a lot of independent measurements that are confirming that climate change is occurring and that the Earth is warming. So it's not just about temperature. If you look at one point that gets raised sometimes is, could this be caused by natural factors? There are natural factors that affect the climate, like volcanoes, the strength of the sun. There's other different cycles based on the Earth's wobble of its rotation and the shape of its orbit around the sun. But if you correct for the natural factors which we know about that cause climate change, essentially the climate should be getting cooler, because the natural factors are actually tending in a cooler direction right now. So the fact that we're seeing actually warmer increases in temperature, the only thing that can really explain it is that scientists can identify is that the greenhouse gases are warming, and because they understand the scientific mechanism for the way that greenhouse gases absorb this infrared heat radiated from the Earth, it's clear that that's what's happening. So there really is not a scientific debate on this, and that's why there's not a lot of real argument about that from the scientific climatologists. And this just shows kind of different projections. Since the humans are putting out greenhouse gases into the atmosphere, there's different scenarios. If we are putting out less greenhouse gases, we're going to see less temperature increases. If we put out more greenhouse gases, we're going to see higher. And so when you're talking about what's going to happen in the future, it's going to somewhat depend on us in terms of how many greenhouse gases we put out. So that's 3 minutes of what climate change is. The next slides I'm going to go through are from the Minnesota State Climatology Office. They're Kenny Blumenfeld slides. They were used in a previous presentation, which Leslie was part of with the city of Minneapolis, and so I'm going to go through some of the key things in there. Kenny did a really nice job of looking at, from the state climatologist office perspective, what do we know, what are people's thoughts about the degree to which we're sure that we're confident that climate change is causing these phenomena that we're observing. The key things that these are in terms of what we're already seeing. We're seeing less extreme cold, we're seeing more extreme rainfall. And the State Climatology Office is pretty confident that the reason we're seeing that is because of the impacts of climate change. So keep that in mind. It'll be repeated less extreme cold, so more milder situations where we would have cold in the winter, more extreme rainfall. They're also seeing, because as I mentioned about the causes of climate change, there's more water vapor in the atmosphere that's contributing to this extreme rainfall, and also in the winter, heavy snowfall. There's not necessarily a trend that they're seeing at this point in terms of severe thunderstorms and tornadoes, and there's no real trend right now in terms of our data, in terms of drought and heat waves. So that's the current situation. Looking ahead 10 years, which is, now it's a little bit less than 10 years, but the state climatology office is confident that we're going to see continued decline in severity and frequency of extreme cold in the state. We've observed it. They feel we're going to continue to observe it over the next 10 years. Extreme rainfall, they feel we're going to see continued increases in the number and size of those events. Likely continue to have more heavy snowfall, increased moisture in the atmosphere, again because of the warming atmosphere is holding more water vapor. You start seeing a little bit more confidence that we're going to be seeing in the next 10 years. Heat waves and drought are becoming more likely as the baseline temperature of the earth increases. Still no real pattern for tornadoes and thunderstorms. They could be increasing or not, but there's no real data for that. So looking ahead beyond 2025, things change a little bit. Again, continued rapid decline in extreme cold in Minnesota. Extreme rainfall, they expect to see unprecedented events. So now we have, some major floods. They expect to see floods to the extent that they would be unprecedented. High, after 2025, like with confidence that we're going to start seeing increases in severity, coverage, and duration of heat waves. So you see in the near term, in the next 10 years, not necessarily going to see it. We feel after 2025, high confidence. Moderately high, you're going to start seeing drought. Not yet, but in the future. And again, less heavy snowfall probably, they're thinking, because there's going to be coming down as rain. And low confidence, again, with the thunderstorms and tornadoes, they're not able to make a real prediction on that. So what are some of the impacts, again, over the next 10 years? Flooding, and these are things that you can see in some of these handouts. Issues could be sewer backup and contamination, drowning, water infrastructure damage, property damage. You've all seen examples of what happens with flooding. With the higher winter and minimum temperatures, increasing freeze-thaw cycles, pavement infrastructure failures, longer growing season, agricultural false starts, extreme heat. This is some infrastructure. You'll hear more from Lisa and other speakers about health impacts, but you'll start seeing people are very vulnerable to heat, especially don't have air conditioning, or people are elderly or vulnerable in other ways. There's different diseases coming in, more cooling requirements, potential for the electrical grid to go down, drought, more stressed vegetation, and reducing the availability of groundwater. Then you start having other issues with wildfires and vegetation and wildlife. So Kenny's main points are warming is well underway in Minnesota. I'm going to show you some more slides. We've still got some more minutes here, and you'll see some more illustrations of this. Cold temperatures are warming the fastest. Annual precipitation is increasing. Extreme rainfall events are increasing. There's no trend for heat waves yet, and no trend for drought yet. Now I'm going to go into some more detail on these things right now. As I mentioned, the average temperatures of Minnesota are increasing. This is the data is showing for the 7-year moving average, which is that line. It's going up about 1/4 degree Fahrenheit a decade. And this is from 1895 to 2015. So it's a pretty long trend. You can see on this graph the average temperature is going up. Now, where is it happening in the state? It's actually the average increase is higher in the northern parts of the state. And think back about the greenhouse effect and what I was explaining in terms of how it works. This is the infrared heat that's that's reflected from the earth, that being absorbed in the atmosphere is raising the temperature of the atmosphere. So the effect of that is more, it's not necessarily when the sun is shining, it's when the cooler times of the year that the heat should be escaping from the earth. And the reason why it's warming these northern regions and winter regions is because when it should be escaping, when there's less sunlight coming in, it's not getting out. So that's why it's not so much that the summer is warming right now, it's just that the cooler times and the winter and the northern regions are warming more. So that there's some scientific logic why we're seeing this kind of a phenomenon, why there's more heating in warming in the northern parts, especially in the polar regions. It's even more. So it's the times and places where the warmth should be leaving the earth that's getting held in. So keep that in mind. It'll help you understand what's going on that you're seeing from this data. Average minimum temperatures, as I mentioned, the average temperature all year round is going up to about 1/4 degree. In the winter in Minnesota, about almost 1/2 degree a decade. So here are some examples of some winter minimum temperatures in the recent years. You can see there's quite a few that are quite high for the minimum temperatures. It should be lower. And if you can see here, compared historically, we saw one back here in the 30s, but otherwise, this is kind of a new phenomenon that you're seeing those. So winter is warming 10 times faster than summer in Minnesota. The average change per decade you can see here since 1970. Essentially, the scientists believe that the impacts of climate change are more measurable since 1970. So the slope of the increase in change has increased since 1970. So when you're looking at historical data, sometimes you'll see even 2 lines. I think in some of these handouts here, there'll be one degree of a level of increase before 1970, and then after 1970, it starts really ramping up. All right, the average highs in the summer are actually going down, is what they're observing. Winter, up a lot. Annual precipitation now, going up. Again, more evaporation, more of from the heat, the warmer air holds more moisture. You would expect average precipitation would go up. It is going up about 1/4 degree a decade. In terms of where in the state, this is trying to show here, this is if you look at the whole 120 years between 1895 and 2015. And there's not necessarily more. There's some regions that are getting more, but I don't know if that's how valid that is in terms of drawing a conclusion. This slide is trying to show that, like what I was saying, since 1970, you're seeing a lot more impacts. So if you look, here's the big picture, the big average, but then if you look just at the most recent years since 1970, when we're starting to see more impacts of climate change, we're seeing higher impacts of increases of precipitation. And then when it rains, there's been coming down more as large numbers of inch events. This just shows that there's been an increase in these large events, heavy rainfall, 2 inches or more. Then there's this mega rainfall. The state climatology office talks about events that are mega rain events, which means that 6 inches of rain come down over about 1,000 square miles or more. If you look back to 1866 to 1987, there were 7 of those events. If you look from 2002 to 2016, there were another 7. So there's an intensification of these heavy rainfall events. And actually 2016 was the first year in which there were 2 of these events in 1 year. So we're seeing acceleration of that. these are just some illustrations of what it's going to look like to have these intense rain events. This is just 4 examples from in the 2000s. You can see there have been in southern Minnesota and northeast Minnesota, just some of these examples. There's other examples too. They're from the National Climate Assessment, again, which is a federal document which is vetted by scientists. They have projections in there, and they're expecting by the mid-century more frequent of these heavy rainfall events in terms of number of days that are going to have them. This is looking at our region of the country. The average summer maximum temperatures, I was saying, there's not really a trend. Here's what it looks like. What we're seeing is the winter temperatures are going up, but here, summer maximum temperatures, there's no real trend that they're observing at this point. They do expect it. You can see here's a recent high, but then if you look back historically, there's plenty of other examples, things that of temperatures that high. So extreme heat is not increasing yet, but as you remember, from 2025 on, they're starting to expect it. Especially, these are additional days above 95 degrees projected by mid-century, again from the National Climate Assessment. You can see we're starting to see large number of days over 95. And again, just check out this National Climate Assessment. It's got great information in it. Drought, again, here's the trend for drought historically. No real trend. These are the wet years, dry years. You look at it, you don't necessarily see a trend there. So that's why the state climatology office says no trend. Actually, you look back in 1934, you had a huge drought then. So nothing that we've seen. But they do. It is projected we're going to see more dry days by mid-century. So that's Kenny Blumenfeld. These are his slides. In terms of what we can do, I'm just going to say a couple words because my time is up and I want to have a chance for a question or two. Climate mitigation and climate adaptation. Climate mitigation means reducing the greenhouse gases. And so that's obviously really important. If you remember back on the graph where there's different scenarios, if the temperature is going to go up a lot more if there's more greenhouse gases. So there are things we can do. And climate adaptation is what I work on. And that's given that we already have these impacts of climate change, what are we going to do about it? And that's kind of the focus of your workshop here, which is exciting that you're thinking about that. Since we're already seeing these climate impacts, we can't just ignore them. And they are going to become more and more severe between adaptation and mitigation. There's ways of reducing, of adapting to climate change that can also reduce greenhouse gases, like urban trees, green roofs, permeable pavers, rain gardens, water conservation. I'm not going to go into that right now, but perhaps at another time we can talk more about it. There's other examples of practices that can also reduce resilience and climate adaptation. So I have the 3 handouts for you. And really these do provide a very useful tool for thinking about this topic. So any questions? Yeah.
Chaos theories. The climate is a big thing, around the whole planet. And, you say that after 2025 things are going to get more extreme. Isn't it, or can you comment on the possibility or the chances of getting in some way to a point where things just go fluid?
I think...
And our ability to affect anything is would be knocked out.
Well, I'm not a climate scientist. My sense is that you're asking about kind of like a nonlinear kind of get over a threshold and then this thing has just kind of become more chaotic. I don't know. I don't know that scientists are projecting that. I honestly don't know. Are there some other folks here that might want to take a stab at that?
Sure.
Yeah, go ahead.
Yeah, hi. I just came in and I want to compliment what you guys have said. The biggest problem we have in the world is toilet paper. We're running out of toilet paper. You can go to a third world country right now, and it's so expensive, and we're like 7 billion human beings, close to that, and everyone goes at least 3 times a day. And going to what you're saying, it's not going to be linear. We're running out of trees, and there are fires everywhere. So in the future, we're going to have a huge problem with having no toilet paper. Something so simple.
Okay, so that's a good example of a nonlinear impact potentially. Does anyone want to address more directly what you're saying? Are we going to get over some threshold where the climate just becomes chaotic? Go ahead.
I guess what I've imagined the future to hold is that there's going to be certain systems, like you have a lake that has so much pollution and there's a tipping point. The lake can handle so much salt and nutrient overload, but it gets to a point and then it's no longer a lake because it just can't sustain living animals and plants, and it doesn't function the same way. So I think that there's going to be certain systems that are going to have that crux where they're going to tip, and we won't necessarily have them, but I don't necessarily think that that's going to happen with everything. Because you're talking about all the different issues and giving us a really broad perspective right now. So I don't think that everything is going to be impacted in the same way, but there are going to be certain things in different areas too, depending on what those pressures are. And that maybe, here in Minnesota, as we're having these discussions, we kind of try to figure out what are those key elements that are most susceptible and that would have the biggest impact if they did cross that tipping point or that threshold.
Good answer. Leslie, you have to just say we want to kind of.
I think it's okay. We have a video that we can cut short if we're having this
Okay, you just said.
I was going to add, we know that methane is bubbling up from the soils in the tundra area, and methane being 31 times more.
I think it was 21.
21, okay. That's a significant issue that a lot of climate scientists are watching, and now we've discovered that the soil in the far north is releasing carbon instead of acting as a carbon sink. So we have some big global natural. Well, that's what the scientists found this summer. Was last summer.
Potentially, would there may be a tipping point?
Oh, there's lots of tipping points,
Yeah,
lots
yeah.
of different ones.
So, and it's areas that we never experienced. We don't have any idea how fast it's going to happen. So we have to keep looking, keep watching, keep monitoring.
I think
These curves are going to change.
scientists are by nature conservative about what they want to state. They want to base it on evidence, and they want to base it on hypotheses that they can confirm. So it's hard to know. I think certainly the risks of things going in unexpected directions of having multiple thresholds that you cross gets increased. But I don't know that we know yet. John, you want to say something?
I want to make just one comment to yours. Dr. James Hansen, the NASA climate researcher who wrote a lot of early papers on this, was in the Twin Cities on Wednesday, and he gave a talk, and he addressed the very issue of methane and will the climate go uncontrollable, essentially. His answer to that was interesting to me, and that was that he doesn't think it's going to happen as rapidly as people say, and that it takes time. The climate is a huge system. It takes a very long time for some of these effects, like methane release, to happen. And there is time to do something about this still. And so, that was one of the kind of comments he had about, is it already too late? His opinion was it's not already too late. There are things where we can't get back to where we were. That's too late. But it isn't going to be a completely doomsday scenario. There's still time to do things about it. And the biggest impact he feels is that it's going to be sea level rise that will take out a lot of ports and cities and places where people are currently living. And I thought that was a very interesting perspective to me because of these methane projections, et cetera. And so I think his message was one that there is hope, that we should keep working.
Yeah.
I'm curious what you know about what the theories are about why the winter is getting warmer and not the summer in Minnesota right now.
Well, that was, my understanding is that based on the fact that the greenhouse gases are keeping in this heat that would otherwise be escaping, in the winter and at night, and so that's why we're seeing more temperature rises then. That's my understanding, but I don't have more of a depth behind that. Would someone else like to comment on that?
Yeah, so like greenhouse gases, it's warmer, but we're also losing snow coverage, which snow causes the albedo effect, which reflects more sunlight out without absorbing it. So with less snow as well, it kind of puts another layer on top of it.
So
Another feedback loop.
the connection to the Arctic and the closer proximity isn't also an issue because there's a lot of that albedo effect going on in the Arctic and that's spreading down into the
It could, yeah, I can't really speak to it, but, go ahead.
Yeah, you showed maximum temperatures in the summer. Seems to me that I've heard that there's data showing that the minimum temperature in the summer is higher than it used to be, so we're not recovering.
I have a little bit of information on that in the next talk too.
There's a lot of health impacts because of that.
Well, this not cooling off as much in the winter makes sense to me when I realize that it's been part of my understanding all my life that a cloudy day is likely to be warmer than a sunny one in the winter because the clouds hold the heat in. And so that's just a macro kind of effect like that.
And it's not necessarily a visible cloud of water vapor, but it's a invisible cloud,
Right.
perhaps, not really cloud, but invisible amount of carbon dioxide in there. So it's like an invisible layer that's acting like that to hold it in. Good analogy. That's why I wanted to just help you to visualize it. It was helpful to me to understand, at least conceptually, but I agree there's more complicated feedback loops, than just the one phenomenon. And I'm glad you point out about the albedo effect and less snow cover.
One more question.
And that is, Minnesota sits on this interesting line between the very dry North and South Dakotas and the much more wet, Wisconsin kind of things. And I'm wondering, looking at these projections going forward, we're going to be on the wetter side. And is that expected to stay true, or are eventually we going to become more like North and South Dakota? Because it makes a huge difference as to whether you're an agricultural, state, or do you basically become more of a bison range?
Looking at those projections based on the current data, it looks like that we're going to become more wetter. But it might not be, there might be more dry periods between, heavy rainfall. So you might have aggregated wetter conditions, more inches per year, but then you might have actually more dry times, maybe in the summer. So it might affect, crops and ecosystems in that way. It wouldn't necessarily be spread out nicely so that it's, so it's kind of, but that's my understanding, is that I have not seen any projection that they're expecting we're going to have more of an arid regime in Minnesota.
And with the agriculture, because we're not cooling down at night, that impacts crops tremendously. So we have to look at growing crops that are grown in Nebraska where it doesn't cool down at night, rather than crops that are grown where it does cool down at night. Because those crops need that difference in temperature. If they don't get it, they don't live. So we may be wetter, but it's too hot in the winter, in the night.
Quick question,
Yeah.
if you can. So I attended a talk by someone from the National Severe Weather Labs, and on their projections about extreme weather, about storms and tornadoes. And this was 3 years ago, and I remember at the time he said that we could expect to see a tornado in February in Minnesota by 2100. We saw a tornado in Minnesota on March 6th
Yeah.
of this year, not 2100.
Mm-hmm.
So even though our state climatologist isn't finding a trend around tornadoes, at the national level, he was talking about a trend of tornadoes coming earlier and potentially coming in the evening. And that tornadoes were there weren't more of them, but when they happened, there would be more at a time, and they were larger, much larger.
Is that Harold Brooks
So,
talk at
yes.
the climate adaptation conference? Yeah, I mean,
Yeah.
I think there's noise in the data when it gets to be for these convective storms and tornadoes, and so I think that the state climatology office is kind of in a wait and see mode. They are kind of looking, post 2025, they raised it a little bit more, but apparently just because of the way they've tracked historically these storms, that you don't have good historical trends, because people are now seeing more of these storms than they used to. So I think it just becomes harder for them to make these projections. The state climatology office is trying to be conservative in what they're saying based on the data that they feel that they can feel confident of. Yeah.
But they're looking at trends. Are they just looking at trends in tornadoes, or are they looking at trends in the kind of weather that causes tornadoes?
Yeah.
So,
I
and the National Severe Weather Lab is looking nationally.
Yeah,
So
hearing
our
that
state
it's-
is looking at our state.
Right, hearing that it's different looking nationally, well, that's because we're including Nebraska and Oklahoma and tornado states. And if there's climate changes, will we become on tornadoes?
Well, I think, you've heard a lot of information, and you're going to have to decide as a group and individually how you want to make meaning out of this. There's a lot of unanswered questions.
Yes.
There's a lot of things we don't know. There's things that are not going to give you definitive answers, but hopefully this will at least have steered you in the direction of, some of what we're seeing, what we're expecting to see, and there are certainly things that you as community members can do to try and prepare for that.
Yes. So now, thank you so much, Paul. And now we're going to learn that we want to give lots of extra time to our science experts.
Thank you, everyone.
Thank you, Paul.
Thank you, Paul.
And now for our next scientist, we have Lisa Strong, who is a neighbor in our neighborhood, and she works for the Department of Health, and where she identifies threats to our health. And she's created this presentation from a number of other presentations. So.
Yes, I want to state right at the outset that I pirated slides without attribution from the State Department of Health website, and if I've taken your slide and forgotten to give you attribution, I apologize. I'm speaking to the camera now. So I only have 20 minutes. I'm going to speak very briefly and very superficially. I'm going to show and identify some health impacts that will be affecting us in this region, in this city. Most of the presentation will be spent on identifying those aspects of climate change. And then I have one slide talking about who's vulnerable, because the answer, of course, is we're all vulnerable. Some of us are more vulnerable.
And we are going to go into different impacts each month as we look at other themes. So this will get picked up.
Exactly. Everything that I'm going to talk about today, we're going to go in more in depth, and you can see the long-term workshop schedule there on the wall. So when we think about climate change and our health, most of the effects come from increased temperature, increased humidity, and extreme precipitation events. Paul had talked about those in the last talk. There's also an aspect that he didn't talk about, which is that our energy comes from burning solid fuels, and so there's also an air pollution aspect to health. So with increased heat and increased air pollutants, increased particles in the air, we end up with heat-related illnesses and death, yes, but they overlap, and those air pollutants cause difficulty breathing, and we end up with heart attacks, strokes, respiratory illness. With the increased temperature and the longer growing season, we're finding that not only is allergy season longer, but the actual allergens have increased ability to create allergic reactions in our bodies. So we're having increased diagnosis of allergies and respiratory illness and increased severity of episodes. With increased humidity, we have bigger storm events. With big storm events, we have flooding, we have injuries and drownings and side effects like wet basements, growing mold, causing increased respiratory illness and allergies. So these things are, they overlap and they build on one another. We also have changes in environment and habitat for pests that spread disease. Leslie told me recently that someone told her that there were 5 new species of ticks in Minnesota identified in the last year or two. Ticks, black-legged ticks in particular, spread Lyme disease. We're seeing that the ticks are living longer, they're having more generations, they're having higher populations, so they're spreading more disease. Same with mosquitoes. Mosquitoes are coming into the area, they're bringing new tropical diseases that we've never seen before. Concurrent with increased flooding, we're also having more uncertainty, so we're having more drought. And I know that there's no, identifiable trend, but we're seeing big wildfires coming from extended drought. Last summer, I remember there were weeks on end where we were smoky here because of big fires in the west. And then we're feeding back into more air pollutants, more respiratory problems. And all of this is causing stress and mental illness because our anxiety levels are shooting out the roof. We're having trouble dealing with the changes that are coming, and that's part of what we want to do here is have a plan, because having a plan reduces anxiety. It also increases our safety if we follow the plan. So that's a few minutes on each of 4 topics. The first one is heat, extreme heat. There's no overall trend perhaps, but if you look at average summer temperatures in 1895 in Minnesota, our average summer temperature was 65 degrees Fahrenheit, and it increases. Here, this is 1935, and then we had kind of a flat period to 1965. This is the 1970 threshold that Paul was talking about, and then it starts going up again. In 2015, our average temperature was 67 degrees. That's 2 degrees higher than in 1895. And by 2069, our average temperature is projected to be an extra 3.5 degrees more, so 71.5 degrees. That's stunning. So when you have more heat, you have more vapor that can be held in the air. That's a physical property. And when there's more vapor in the air, when you sweat, it doesn't evaporate off your skin. And when it can't evaporate, it's the evaporation of sweat off your skin that cools you off. And when it's humid, the sweat doesn't evaporate and you overheat. And that's when you run into heat-related risk from heat-related illnesses. And the number of days with the dew point temperatures of over 70 is expected to go up over time. So extreme heat, we're talking about heat stress, heat exhaustion, and stroke. And I have some statistics here. In 2000, in the year 2000 in Minnesota, there were 330 hospitalizations for heat-related illness. 330. Between 2000 and 2010, there were 35 deaths directly attributed to heat in Minnesota. Before 2010, I don't think there were any. And then there's another problem that comes when people get hot, they get irritable. And for every 2-degree temperature rise, which we've already seen, there's a predicted 24,000 additional assaults or murders in the US. So we have to think about people being unable to cope with heat and lashing out at one another. So I'm going to move on now to air pollutants. When you have increased heat events, you have increased wind because the air wants to move from where it's cold to where it's hot. Where it's hot, the heat rises over the land and the air rushes in from cooler areas and you get big wind. When you're in the middle of a very large area of heated land, you get very, very still air. So we'll have both increases in stagnation events, where pollutants will build up, people have trouble breathing, and increased incidences of big wind, where, you know, trees blow over and roofs blow off. And when the temperature goes up, people turn on their air conditioners if they have them. More fuel is burned, and then you have more particulates and more things like nitrous oxides and chemicals that irritate people's lungs being put into the air. Actually, plants themselves, when it warms up, they outgas organic materials, which can irritate airways. The length of the allergy season is increasing. In Minnesota, I think this is my next slide. Yes. In Minnesota, between 1995 and 2015, our ragweed season increased by 18 days. And in this time period, the diagnoses of allergies has increased by 20%. And once you are sensitized to an allergen, you get more and more sensitized to it, and episodes get more.
Is ragweed a noxious weed in Minnesota?
Who's a master
It's
gardener?
a native plant in Minnesota.
It's not,
So it's not.
It's not a showy plant. A lot of
No.
people,
Goldenrod.
right,
Yeah.
mistake goldenrod for ragweed.
Yeah.
I'm speaking to a knowledgeable crowd. That's
Yeah.
helpful. Okay, now I'm going to skip right over to flooding. The number of storms in Minnesota with more than 3 inches in a rain event has gone up over 100% in the past 50 years. We've had, in 2007, we had a record rainfall, over 15 inches in 24 hours, and 7 people died in that rainfall event. That was down in the southeast corner of the state. In 2012, we had 10 inches of rain in 2 days. It caused severe flash flooding and river flooding. The St. Louis River rose 10 feet in 24 hours and crested over 16 feet. It caused huge property damage. So we're going to be seeing more flooding and more events. And I want to just talk about driving safety, because we're not used to flooding events here. 6 inches, that's this far, will stall your car. 1 foot will push your car down the street or into the river, or 2 feet will carry away an SUV or a big pickup truck. So you don't want to mess around when you see a flood. You don't know if the pavement is intact underneath that floodwater. Don't go in if you don't know.
Not only, I mean, I'm thinking, memorize the terrain so you know where it's likely to be deeper than that. But yeah, if the pavement breaks up, then it's going to be deeper, and memory doesn't help.
Yeah. Experts, people who know more than I do, say if you can get out of your car, do. Abandon your car. Don't try and save your car. Your life is not worth it. Because if you get swept away in your car, all bets are off. Water is very powerful. 2 inches can sweep you off your feet. So flooding and drought, mental stress, decreased safety and availability of drinking water. When the water rushes over pavement, it picks up oil, it picks up pesticides, fertilizers. You don't know that your drinking water is going to be safe. It can overwhelm the water treatment plants. You can be injured or drowned. Flooding can worsen respiratory ailments because of mold growth. We're going to be separated from each other by roads that are impassable. Maybe essential services, fire and police maybe can't get to us. Maybe your house will be uninhabitable. And so we have to think about different ways that we can mitigate these issues as a community, because if my house is not safe to live in, do I have a neighbor I can move in with? And then the fourth thing I'm going to just briefly touch on is vector-borne disease. Lyme disease is carried by ticks. West Nile virus is carried by mosquitoes. There are other vector-borne diseases. But there's also, we're seeing algal blooms that are toxic. The bright green algae that you see growing on lakes and ponds, don't let your dog drink it. We're seeing an increased number of dog deaths. And actually at the Department of Health, we're now trying to figure out a way to test for this and warn people, because it's an up and coming issue that's never been a problem before.
Not all algae is good for you.
No. No, and the one that people eat, which is spirulina, doesn't grow here. Yet. Okay, so there are other health aspects that I didn't feel like I had time to touch on, but those are the main ones. I want to just really emphasize, we're all vulnerable to these. How do you keep yourself from getting stung by a mosquito? Well, you don't, really. You can take precautions, but everyone gets stung by mosquitoes. People who are more vulnerable are people who have these attributes. And this has been divided into flexible vulnerability factors, which are things that are perhaps not permanent, and fixed vulnerability factors, which are a result of either biology or perhaps historical trends of inequity. So the flexible things are, the flexible vulnerability factors are no access to a vehicle. You might not be able to flee if there's a coming threat. If there is big air pollution, you may not be able to go somewhere where the air is better. People who don't have central air conditioning are more vulnerable to heat. People who are renters don't have control over their space, so they can't make permanent changes to their environment that make them safer or more comfortable. People who live in poverty have problems because they can't afford things that might help them be more comfortable or safer. People who don't speak English might have less access to information or ability to hear about threats that are arriving. The fixed vulnerability factors are people who are elderly or very young. Your neighbors who are elderly or have very young children, you know, they might benefit if you knocked on their door when a storm has just passed and asked them, do you have electricity? Do you have everything you need? Can I help you? People of color, I'm sorry, but it's just a problem because they have less resources, they have less access to systems of power that can help them. And people with disabilities may not be able to respond to an emergency in a reasonable way. Speaking about hope, I wanted to end my talk with a quote from John Leach, who's a military survival instructor. He spent his whole career looking at who survives and who doesn't. And what he's found is that people who survive are not braver or more heroic than anyone else, but they have become better prepared. And that's what we're going to try and do. We're going to try and move into the future better prepared, safer, and more secure.
on the quote there, something that I was thinking about as you were talking, because I go backpacking a lot, and a lot of the things that we learn backpacking is like, where are you going? What's the climate going to be like? What kind of animals might be out there that you're going to interact with? Filtering your water, all these kind of things. And I was just making notes about the resilience in the community that maybe people have backpacking water filters at home as a backup, you know, because maybe the water is just going to be contaminated for a week, and then they're going to get the systems back online, and we're going to be fine. What are you going to do for that people? Everybody's bought all the water at the grocery store, you know? So like kind of things like that about just being prepared and makes me think of backpacking preparedness. But I was wondering something in particular about the vehicles when you were saying that it's 6 inches of driving through. Is it, because I've seen people get stalled out even in rain events in the city in the past. So is it that the water gets into the exhaust system? Do you know? Because sometimes people drive through these things and they're just fine, and they're, you know, little 4-door cars, and then another person in another 4-door car gets stuck. And so I'm wondering, do you know what it is about the water in the vehicle that makes it stall out?
I think I'm not,
We have an engineer, I wonder if.
I'm an engineer.
Oh,
There you are. Are you a combustion engineer?
Yeah, one of the things.
Okay,
One is real hard on electrical systems. And of course, the car won't run with the electrical system shorted out, so.
So it might have to do with the age of the vehicle and how well insulated the conductive
Or if it
systems are?
splashes up into the alternator, there's all sorts of possibilities.
If your wiring's got road grime on it, it will absorb moisture, and that's more likely to short out. So it's really vehicle specific in many
And
ways.
do you want to take a chance?
Yeah.
So
If the water's only 2 inches deep, you could probably walk through it.
How fast is it moving?
Yeah.
2 inches in a puddle is very different from 2 inches rushing down the gutter.
I've had the experience of having my feet swept out from under me. It's amazing. It just was unbelievable.
Very scary.
Yeah.
Leslie?
Part of why I'm so passionate about this is that people who know me know I lost a car in a flash flood in our neighborhood on 31st Avenue. And maybe there was 6 inches of water and it stalled out my car. But the water was coming so fast that it very quickly was almost up to the window. I mean, I'm like sitting there thinking, what should I do? How am I going to move this car all by myself, a station wagon? And in a couple of minutes, it was like, okay, now it's up to the door. And now it's up to the door handle. And I'm rolling down the window and climbing out the window. And my car went completely underwater. Like, it just happened, and that took less than that's probably like 20 minutes to happen. It was just way faster than I would have imagined.
Thank you for your attention.
Yep.